Welcome back, ladies and gentlemen, to Akima Academy. Today we are looking at the question 7 of 2021 Novdec. Okay, now that particular question was also a word problem which involves a simultaneous equation. Now I have an excerpt of the questions over here. The full question can be found in our Telegram page so follow the link under the video or the link in the comment section, okay, to join the Telegram page so that you can have full access to the questions over there. Now if you look at the question, this is an excerpt. The question said there was an athletics competition, and in that particular competition 812 tickets were sold. In that particular competition 812 tickets were sold. Total money obtained was $1,912. $1,912. Then looking at it, they said students were paid $2 each. Okay, the non-students were paid $3 each. So it means the competition was the group of people who attended the competition were students and non-students, and students paid $2 each, whilst non-students paid $3 each. Good. Now the question went ahead and said how many more students than non-students were present. How many more students than non-students were present? Now, with this question over here, before we can solve, you can find the number of students, which were more than the non-student Then it means we should be able to find the number of students who attended the competition and the number of non-students who attended the competition. Okay, good. So when you get such a question, how do we solve such questions? Okay, now immediately you realize that we have two groups of people. It is talking about two groups of people. Then you realize that we are talking about simultaneous equation. Here you can see the two groups of people that we are looking at are students and non-students. Okay, so in this case, how many students attended and how many non-students attended? Now let's bring our mind back to the house. Okay, questions of this nature is better solved when you bring your mind back to the house. Assuming we are selling oranges. Okay, assuming we are selling oranges, and this oranges has been grouped into two. We have the 3 CDs and the 2 CDs. Now if I have 10 oranges, okay, if I have 10 oranges for a price of for the 2 CDs, okay, 10 oranges, and each of them is sold for 2 CDs, how am I going to get the total amount of the oranges, of the 2 CDs oranges, when they are all being sold? Okay, so if you look at it, we have 10 oranges and each of the oranges is what? 2 Ghana cedis. So how do I calculate for the total amount that I will generate after selling all the 10 oranges? Okay, so what do? We take the 2 CDs multiplied by the number of what? Oranges. Okay, we take the 2 CDs multiplied by the number of oranges. So I have 10 oranges, each of them is 2 CDs. So to know the amount that I'm going to get after selling the 10 oranges, then I have to multiply the 2 by the 10, then I'll get 20 CDs, meaning that at the end of the day, after selling all the 10 oranges, I'm going to have an amount of what? 20 Ghana cedis. Okay, the same applies to the 3 CDs. If you have 5 oranges, each of them is sold for 3 CDs. You multiply the 3 by the 5 to get the total amount that you are going to get after selling what? That particular 5 oranges, if you sell all of them. Okay, good. So that's the principle, that's the procedure we use over here. Now, because the two groups, we are not aware of them. The number of students who attended, we don't know. And the number of non-students who also attended, we don't know. Okay, because of that, what we do is, okay, we state it nicely. Say let X and Y be the number of students and non-students who attended the competition, okay, respectively. Simply meaning that X represent the number of students who attended the competition, and Y should represent the number of students who attended the number of non-students. Okay, the number of non-students who attended the competition. You state it nicely like this. Then we are now sure that we know the number of students who attended the competition. Now our number of students who attended the competition is X, and the number of students, the number of non-students who attended the competition is now what? Y. Okay. Now in this case, they are saying that the ticket which was sold to them is 812. Okay, so we have 812 tickets which was sold to these two group of people. Okay, these two group of people. So we have 812, the number of tickets sold to them. So it means that if we add the number of students who attended the competition to the number of non-students who attended the competition, if we add them together, we should get the total tickets, okay, which is 812. Understand it? Because the number of students, we have the total ticket to be 812, which was sold to them. Now it was sold to which people? Students and non-students. Okay, but the issue is we don't know the number of non-students who attended it and the number of students who attended it. Okay, but we know that the 812 were sold to students and non-students. So it means that if we add the students and non-students together, we should get the total number of tickets which were sold. Okay, if we add the number of students and the non-students together, we should get the total number of tickets which were sold. Then we can peacefully say that this one is our equation 1. Okay, this becomes our equation 1. Now we know that X students attended the competition. X student attended the competition. Now if X students attended the competition and each of the X students paid $2 each, okay, paid $2 each. So how am I going to get the money that was generated from the students who attended the competition? Okay, so each student from the X paid $2 to enter into the competition. So for me to get the number of students, so for me to get the total amount which was generated from the students who attended the competition, what do we have to do? Each student pay $2. So what I have to do is I have to take the $2, just like the oranges. Okay, you multiply the 2 CDs by the 10 oranges to get 20 CDs to be what? The total amount that you'll be getting after selling the 10 oranges. So in this case too, we have 2 CDs each from the X. Therefore, to get the total amount from the students, then we have to multiply the $2 by the number of students who attended it, which is X. So it means that we are going to have 2X to represent the sum of money, okay? The sum of money that we are going to get when the students attended the competition, okay? So 2 times the number of students who attended the competition will give us the total money which will be generated from the students. In the same way, the non-students too, we have $3 each, and we know that the number of non-students who attended the competition is Y. So to get the total amount of money that was generated from the non-students, that means we have to multiply the $3 each by the total number of non-students who attended the competition, which is Y. Okay, now, so we have 3Y. So 3Y over here simply means $3 each multiplied by the number of non-students who attended the competition. $2 multiplied by the number of students who attended the competition. Now, this two money, okay, when you multiply, we are going to get the total amount of money. It's going to give us the accrued money that we'll be getting from what? The students and the non-students. So when we combine the two money together, when we combine them, it means if you put them together, we should get the total amount they had over here, which is 1,912. So it means that the money generated from the students plus the money generated from the non-students should give us $1,912. Okay, now this one becomes our equation 2. Okay, becomes equation 2. So this is how to generate the two equations. Okay, you take your time, look out for the hidden question, the groups that we are dealing with that we don't know, then we represent them with variables. Okay, then we represent them with variables. So here you can see we use X and Y to represent them. You can also choose to use any variable of your choice, A, B, C up to Z, okay, to represent them. Now, so when you put them together, okay, the two groups, when we put them together, it should be equal to the number of tickets which were sold, because the tickets were sold to the students and the non-students. So if you put the number of students and the non-students together, we should get the total number of tickets that was sold. Now, we know the number of students and the number of non-students who attended. So when we take each of them, students paid $2 each. So you take the $2 multiplied by the number of students who attended to get the total money which the students brought to the competition, or which we gain from what? The students. Okay, so we do the same for the non-students. Each non-student paid $3. So what we do over here is we multiply the $3 by the number of non-students who attended the competition, which is Y. So these two money over here, the money generated from the number of students who attended and the number of non-students who attended, when we put them together, we should get the total money, which was given to us, 1,912. We should get them in that manner. Then our two equations are nicely generated over here. Okay, good. So from here, we can solve them using the simultaneous equation method. We have many ways of solving them. You have the elimination method. You can also choose to use the substitution method, which are the two common methods that we normally use in solving simultaneous equations. Okay, so let's use the the substitution method over here. So here, from equation 1, we can make one of the variables the subject. We can choose to make X the subject, or we can choose to make Y the subject. So if we are making X the subject, then it means Y should move to the other side of the equation. Okay, it means Y should move to the other side of the equation. So from equation 1, X will be equals to 812 minus Y. Okay, 812 minus Y, because Y is going. So we can put X over here in equation 2. Okay, you put X over here in equation 2. So wherever we see X in equation 2, we put we have X here, so we put the values over there, which is 812 minus Y. Okay, then plus 3Y is over here, equals 1912. Okay, so we can expand this one over here. So we have 2 times 2, we have 4, then we have 2, then we have 16, right? So we have 1624 over here. Then 2 times minus y, and we are going to have minus 2y plus 3y equals 1912. Okay, so from here we can group them. Let's send this one to the other side. We have minus 2y plus 3y should give us y, right? Y. Then this one will move to the other side. So we are going to have 1912 minus 1624. Okay, good. So from here we can say our y equals, so here you do the subtraction. You can use the calculator to point this. You have 8 over here. We have here 2 to be 8. Then we have 2 over here. Then 1 will cancel 1 and move out. So we have 288 as our value of y. Okay, so now we know the number of students, the number of, because y is representing the non-student. So the number of non-students who attended the competition are 288. Very simple over here. So from here we can just put this one inside the equation, our equation that we generated over here, which is x, the equation of x. Okay, so we know that x equals 812 minus y. Okay, so our x will be equals to 812 minus 288, and this one you can use the calculator to point this one. Okay, so that you can have your x to be equals to 524. Okay, for our x. So this is telling us that the number of students who attended the competition were 524, whilst the number of non-students who attended the competition were 288. Very simple over here. Good. Now, this is not what the question was demanding. The question says, how many more students than non-students were present? How many more students than non-students were present? So if you want to know the number of more students than non-students, that means you have to take the non-students, subtract it from what? The students who attended. Then the remaining becomes the difference. Okay, the remaining becomes the difference. So we are going to have you know the number of students who attended, which is x, is 524 minus the number of non-students who attended, which is 288. Okay, so at this point, when you do the subtraction, then you have 236. Okay, yeah, 236. You can use the calculator to point this one so that it will be easy for you. So you have 236 more students. Okay, so you can just simplify it here. More students than non-students were present. Okay, so we are having, when we subtracted the number of students, this is the number of students who attended the competition, which is 524. The number of non-students which who attended the competition, 288. So you do the subtraction, we are having 236. So meaning that we have 236 more students than non-students at the competition. Okay, so the question which was demanded, they said the number of students, which how many more students? So there were 236 more students than non-students at the competition. Okay, so you can see that it looks a little bit tricky, but if you follow it gradually, it is going to become part of you. Okay, so just take your time, go over it, and analyze it well. Okay, and anytime you have similar question, when you get similar question, at times they might not use how do you call it? They might not use students and non-students. Sometimes they can use animals, they can use items and certain things. So the only thing is just master them. And when you get a similar question, you just follow the same principle. Okay, you follow it in that order. You look out for the two items which are missing, represent them with variables. Then when you add them, it should give you the total number. Then when it is being multiplied by the money, you should get the total money of each of them. When you add the monies together, you should get the total money which was obtained. Then you get your two equations over there and just simplify them. Okay, this is how to solve the question 7a. Okay, now let's look at the question 7b. Let's add that one. In addition, that one is very simple and short. Okay, so if you look at the B part, it is also a word problem. You see, the problem of the word problem is that you just have to take your time and read them one after the other and analyze it as you are reading them. Okay, so here if you look at this, they said twice the first. This one is also an excerpt. Okay, the actual question is at the page. You can go and access the actual question. Okay, so they said two numbers, and from the two numbers they didn't mention them to us, but they said twice of the first number added to the second number is 21. You see, this sentence over here becomes the first equation. So immediately you look at you see it in this manner. They should tell you that you are talking about simultaneous equations over here. So you can see that they said twice the first number added to the second number is there is over here most of the time represent equal sign. Okay, most of the times it represents equal sign. So twice the first number added to the second number is 21. So we don't know these numbers, so what we have to do is represent these numbers with variables. So we can just state it nicely. Let the first number be x. Okay, x again. I like x a lot, but you can also choose to use any variable of your choice. Okay, it's not compulsory for you to use x all the time. You can use a different variable of your so here we have let the first number be x and the second number be y. Okay, let's use them. That's it. Okay, they are all the same thing. You can use any variable for your choice, but I prefer using x and y over here. So meaning that the first number is x and the second number is y. So let's come to the question. They said twice the first number, twice the first. So this x. So twice, 2 times x. Okay, twice. So 2 times x. Addition to the second number is y. So to the second y is 21, so equals 21. Equation 1. Okay, they're using the same principle over here for the second statement. Twice the second, so here the second number, where is our second number? Our second number is y. Twice the second, so 2y. Okay, twice the second added to the first, added plus the first over here is our x, equals 27, so equals 27 over here. Okay, and this one represents our equation 2. So here you have another simultaneous equation here, so you can either solve them by substitution or elimination, which is the two common methods. So let's use substitution. So if we are to use substitution from equation 1, we can say that y equals 21 minus 2x. Okay, we are making y the subject over here, so we are sending 2x to the other side of the equation. Okay, so y equals 21 minus 2x. Okay, so from there we can put this value over here in equation 2. Okay, we put this one in equation 2. So here, wherever we see y, we put 21 minus 2x. So y is over here, so we write our 2, open bracket, 21 minus 2x, which is representing our y, plus x equals 27. Okay, then you expand this one. 2 times 21 will give us 42. Then 2 times minus 2x, so we have minus 4x, plus x, which is over here, equals 27. Okay, So from this side, you can see that we have minus 4x plus x will give us minus 3x. Minus 3x, because it is minus, let's send to the other side of the equation so that we bring this one here. So 42 will rest here. Then we bring the 27, which is make minus 27, equals the minus 3x over here is crossing to the other side. So it becomes 3x positive. Okay. So if we do the subtraction over here, it means we are going to get that's 15, right? That's 15. Good. So we have 15 here equals 3x. Okay. Divide this by 3, here by 3, and this will cancel that. Therefore, our x is equals to 5. Okay, here 1, here 5. So our x is 5. So meaning that our first number is which is represented by x is 5. Our first number is 5. So let's look at the second. So with the equation that we generated earlier, which is y equals 21 minus 2x, we can use this equation to find our value of y. Now that we know our x is 5. So from this equation, we have y equals 21 minus 2x, right? So x is 5, so y equals 21 minus 2 multiplying 5. So y will be equals to 21 minus 10, and therefore our y is equals to 11. Okay, these are the two values that they are looking for. So our first number is 5, and the second number that they are looking for is 11. Okay, it looks very simple. So this is the question 7, 7A and 7B of the 2021 Novdec. Maybe you might get similar questions. Just they'll change the values, they'll change the principle, but we use the same steps. Okay, they might change the values and items in it, but we use the same steps in solving them. Okay, you take your time, read them one after the other, then bring out the two simultaneous equations, represent the unknown variables with the unknown items with variables. Okay, so that you use them to solve it and you are good to go. So don't forget to subscribe and share it to your family and friends. Let them also enjoy. And we have our Telegram page under the comment section. So use the comment section, go to the comment section, use the link over there to join the Telegram page and have access to the entire questions. Thank you. Bye bye.